solve equation ax minus y plus a in exponent y minus x is equal with question mark. So we have those three equations and we want to solve the third equation. But before I solve the third equation, let me make some restriction. Let a and b are element of a positive integers. And then a, let a greater than or equal with 2, and let b is a greater or equal with 2. So we have this restriction. And now I'm taking the first equation, a in exponent x. So let me take a in exponent x plus a in exponent y is equal with b. Now I'm going to square this equation. If I'm squaring this equation, I'm going to have as follows. Ax plus a in exponent y square is equal with a b square. Now if I'm expanding this binomial, if I'm expanding, it's going to be a in exponent 2x plus a 2 times a in exponent x times a in exponent y plus a in exponent 2y is equal with a b square. So I have this case here, this scenario. If I'm taking the second equation, so let me write the different color. If I'm taking the second equation, a in exponent x plus y is equal with b over 2. But this a in exponent x plus y, I can write as follows. I can write a in exponent x times a in exponent y is equal with b over 2. And now I have this ax to a in exponent x a y. And instead of this ax a in a y, I'm going to substitute by b over 2. So what I'm going to have in here. So then I'm going to have this in this form. A in exponent 2x plus a 2 times, and instead of this one here, ax times ay, I'm going to substitute b over 2. So let me substitute b over 2. And this is equal plus a in exponent 2y is equal to the b square. But now this 2 here I'm going to simplify, 2 with a 2, and remains b here. And because I want this equation to solve for a into x and a to y, I'm going to subtract in both sides by minus b. So I'm going minus b here and minus b on this side. And this equation is going to take the form as follows. So a into x plus a into y is going to remain in this side because these two are going to simplify. So here I have a, because b here with a minus b is a 0, and b squared minus b, so I can write this one as a b squared minus b. And now this one I can frame this equation. When I need, I'm going to use it. And now I'm taking the third equation, which I'm trying to find, a in exponent x minus y plus a in exponent y minus x. So the third equation, which is ax minus y plus ay minus x is equal with what? So now this ax minus ay I can write as ax times a negative y plus the other one I can write a in exponent y times a in exponent minus x. And this equation we can write in this form, a in x divided by a in y, and this is a plus a in y divided by a in x. A in y divided by a in x. But now if I want to make the same denominator, I'm going this one to multiply by a in exponent x times a in exponent x, and this one a in exponent y times a in exponent y. And as we see here, we have the same denominator. And because I have the same denominator, this one I can write in this form. So I'm just distributing. Ax times ax is a in exponent 2x plus ay times ay is a in exponent 2y. On the other hand, the denominator is the same. Ay times ax is equal with ax times ay. So I can write here ax times ay. But what is this equal with? But as we see here on the top numerator, a to x plus a to y we already have here in this blue box. which happens to be b squared minus b. So I'm going to substitute by b squared minus b. On the other hand, instead of ax times ay, I have the other equation, which is here. So I'm going to frame ax times ay is b over 2. So it's a b over 2. When we are simplifying this equation, this expression, we are going to get a 2 times b squared minus b is divided by b. In the other words, so finally, this equation ax minus y plus a in exponent y minus x is equal with the 2 times b squared minus b. Everything is divided by b.